This video, we're going to check out how to use the determinant trick in order to find the inverse of a 2 by 2 matrix. And so a couple different things that we want to look at beforehand. Make sure, obviously, that you know how to find the determinant of a 2 by 2 first, because we need to use that. The other thing that we need to kind of define is what we call the adjoint matrix. The adjoint matrix. And so if we start off with a matrix A, B, C, D, the adjoint matrix, essentially what we're going to do is take these two along this diagonal and switch those two. So now the entry in the top left becomes our entry in the bottom right, and the entry in the bottom right becomes the entry in the top left. So that's the first thing, is we swap the first diagonal, what I'm going to call the first diagonal, and that's really because we usually start in the top left. Our first diagonal goes top left to bottom right. Swap the first diagonal. The second thing that we do is we negate the second diagonal, or the other diagonal. So this diagonal here, maybe I shouldn't draw an arrow, but this diagonal here gets negated. So we negate the other diagonal. And if we do those two things, that gives us what's called the adjoint matrix. So this whole little trick basically revolves around you being able to find the determinant and multiplying the reciprocal of the determinant times the adjoint matrix that we just kind of went through. And so I'm going to go through a few examples here, just using the determinant trick to find the inverse of a matrix. And this is a really nice, quick, easy way to be able to do this. Now, you do need to be able to do this what we call analytically, or using a system of equations as well. So make sure that you know both methods. This is a much quicker, easier way, although sometimes it can get a little bit messy with particular matrices. So let's go ahead and get to it. So the first example we've got, A, is this. So what I want to do is find a inverse using the determinant trick. So the first thing that I need to find is the determinant of A. And to find the determinant of A, we've got 6 times 2 minus 11 times 1. So I'm just multiplying these diagonals and then finding the difference between them. This is 12 minus 11, so that's equal to 1. The second thing I need is a adjoint. So I'm going to come up here and kind of define my adjoint matrix. And in order to do that, I take the first diagonal and I swap those entries. So those two entries trade places, and then I negate the other entries. So that's my adjoint matrix for this particular one. So in order to find the inverse, my inverse matrix is going to be given by 1 over the determinant of the original matrix, the determinant of this guy, which I just figured out was 1. And then I'm going to multiply that by the adjoint matrix, which is 2. -1, -11, and 6. So very simple computation here. I can find my inverse by taking 1 over 1, which I know is just 1, and multiplying it by that adjoint matrix. And so my inverse is 2, -1, -11, and 6. Nice and easy because our determinant didn't get real ugly there. It was nice and clean. All right, so a nice simple example to start us off. Let's go ahead and try this with the second one then. First thing I need is a determinant. So I need the determinant of A. 1 times -7 minus 3 times -3. So my determinant ends up being -7 plus 9, which gives me 2. And my adjoint matrix, remember we swap the first diagonal, so I end up with -7 and a 1, and then these two get negated, so I end up with a +3 in the top right and a -3 in the bottom left. So I want to find the inverse. My inverse is simply 1 over the determinant of A times that adjoint matrix. And simplifying, I end up with -7/2 for my top left entry, 3/2 for my top right, -3/2 for my bottom left, and 1/2 for my bottom right. And there's my inverse, nice and quick and easy.